Here we have two trigonometric identities. So tan x is equal or equivalent to sine x over cos x. So we can say sine x is so, the opposite over the hypotenuse, and cos x is ka, the adjacent over the hypotenuse. So if you divide sine x by cos x, the opposite over the hypotenuse divided by the adjacent over the hypotenuse, you could either divide the top, divide the bottom, and that will go straight to O over A. Or you could say, when you divide fractions, you change it to a times and flip over the second one. So that's OH over HA. The H's cancel out. It's O divided by A. So when you have sine divided by cos, you get O over A, which is, of course, tan. So sine divided by cos makes tan. The other one we have here, cos squared x plus sine squared x equals 1. So this one comes from the Pythagoras' theorem. So if we have the adjacent squared plus the opposite squared, it equals the hypotenuse squared. That's Pythagoras' theorem. That works for any right-angled triangle. And then let's just divide through by hypotenuse squared. So a squared over h squared plus o squared over h squared equals h squared over h squared. And a squared over h squared we can write as a over h squared. O squared over h squared we'll write as o over h squared. And h squared over h squared, that's 1. So a over h, that's cos. And when cos is squared, we don't write cos x squared, we write cos squared x. And again, same with sine squared x. So this means cos x squared and sine x squared, but we just write them as cos squared x and sine squared x. So we've got two identities here that we need to remember. So tan theta or tan x is sine x over cos x, and cos squared x plus sine squared x equals 1. This question says simplify the expressions. So the first one, 5 sine squared theta plus 5 cos squared theta. If we factorized out the 5 sine squared theta plus cos squared theta, and sine squared theta plus cos squared theta is 1. So 5 times 1, this is just 5. 1 minus sine squared 3 theta. So this one maybe doesn't look as straightforward, but remember, cos squared theta plus sine squared theta equals 1. So whenever we have a sine squared theta, we can change it into a cos squared theta. So I can change sine squared theta into 1 minus cos squared theta. So it'd be 1 minus cos squared, and then the angle is 3 theta. So I've changed sine squared into 1 minus cos squared. I've just rearranged cos squared theta plus sine squared theta equals 1. It doesn't matter if the angle is 3 theta or 4 theta or x. As long as these angles are the same, this identity works. So 1 minus 1 is nothing. 1 minus cos squared 3 theta is just cos squared 3 theta. Part C, square root of 1 minus cos squared 3 theta. So again, we can do exactly the same thing. Cos squared 3 theta can be changed into 1 minus sine squared 3 theta. So we've got 1 minus sine squared 3 theta. 1 minus 1 is nothing. 1 minus minus sine squared 3 theta is just sine squared 3 theta. We've got sine is squared, sine 3 theta is squared, are then square rooted, and they cancel out. The square and the square root cancel. It's just sine 3 theta. And the last one, tan theta times cos theta. So the other identity, we can change tan theta into sine theta divided by cos theta. So we've got sine theta times cos theta and divided by cos theta. So it's the same as sine theta cos theta over cos theta. The cos thetas cancel. We've just got sine theta left. Okay, some for you to try. Pause the video and give them a go. So the first one, cos squared 3 theta plus sine squared 3 theta. Cos squared angle plus sine squared angle equals 1. So that is just 1. So it doesn't matter if we've changed the angle. Cos squared theta plus sine squared theta equals 1. The second one, sine theta over cos theta, we can change into tan theta. So this one is 2 tan theta. Part C, 1 minus sine squared theta. You can see if we rearrange the identity, take sine theta away from both sides, that is cos theta. Cos squared theta, sorry. So 1 minus sine squared theta is cos squared theta. So this is cos squared x in this case, divided by cos x. Cos squared x divided by cos x is just cos x. We divide top and bottom by cos x, and we just get cos x. And part D, cos theta sine squared theta plus cos cubed theta. So we can factorize out a cos. So cos theta, and that leaves us with sine squared theta plus cos squared theta. And we know sine squared theta plus cos squared theta is just 1. So we have cos theta. This one says prove that. And we've got the left side, cos 4 theta minus sine 4 theta is equivalent to 2 cos squared theta minus 1. So when we have one of these questions, we have to take the left side, usually the left side, and turn it into the right side. So we're just going to start with cos 4 theta minus sine 4 theta. So something to always look out for is a difference of 2 squares. And I can see I've got a minus in between 2 things that are squared. So I'm going to use that. I'm going to have cos squared theta plus sine squared theta and cos squared theta minus sine squared theta. Cos squared theta plus sine squared theta is 1. I've just got cos squared theta minus sine squared theta. I want 2 cos squared theta minus 1. So I'm going to change the sine squared theta. So because cos squared theta plus sine squared theta equals 1, sine squared theta I can change into 1 minus cos squared theta. So cos squared theta minus 1 minus cos squared theta. Minus 1, I'll just write as minus 1, minus cos squared theta. When we minus a minus, we plus. So we've got cos squared theta plus cos squared theta, which is 2 cos squared theta minus, and we've got minus 1. One for you to try. Pause the video and give it a go. So prove that sine theta, cos theta, tan theta is the same as sine squared theta. So we've got a tan in this one, so we can change it into sine over cos. So sine theta cos theta times sine theta over cos theta. So that's sine squared theta times cos theta divided by cos theta. The cos thetas cancel. We just have sine squared theta. And another one, prove that 1 over cos x minus cos x is the same as sine x tan x. So let's try and add these fractions together. So to add fractions together, we need the denominators to be the same. So we'd have 1 over cos x, and to make this is over 1 at the moment. To make the denominators the same, we'll times top and bottom by cos x. That would be cos squared x over cos x. Now we can add them. We'll have 1 minus cos squared x on top over cos x on the bottom. 1 minus cos squared x. Remember, cos squared x plus sine squared x is equal to 1. So 1 minus cos squared x, if we take away cos squared x from both sides, is sine squared x. That's sine squared x over cos x. And sine squared x means sine x times sine x. And sine x over cos makes tan. That's tan x times sine x, and I'll write it the other way around, sine x tan x. One for you to try. Pause the video, give it a go. So prove that tan theta plus 1 over tan theta is equivalent to 1 over sine theta cos theta. So we can change tan into sine over cos. Probably the easiest thing to do. So let's write sine theta over cos theta. And we've got 1 over tan theta. If we've got 1 over sine theta over cos theta, make a note of this. So 1 over sine theta over cos theta. What happens there? It's the same as 1 divided by sine theta over cos theta. It flips it over. So if you change a divide to a times, you flip over the second fraction. So this is sine theta over cos theta plus cos theta over sine theta. Now we want to add them together. So let's make the denominators the same. Times top and bottom of our first one by sine theta. That'll be sine squared theta over sine theta cos theta. Times top and bottom of the second one by cos theta. That'll be cos squared theta over sine theta cos theta. Now we can add them together. So we've got sine squared theta plus cos squared theta over sine theta cos theta. Sine squared theta plus cos squared theta is 1. So we've got 1 over sine theta cos theta. Given that sine theta equals 3/5 and theta is obtuse, obtuse means between 90 and 180 degrees. Find the values of cos theta and tan theta. So if it's obtuse, only sine is positive. So the other two are going to be negative. So cos theta and tan theta will be negative. So we know that because it's obtuse. Now let's look at the angle. Sine theta is 3/5. So when we get one of these, when we get sine theta equals a fraction, we can draw a right angle triangle. So if this is theta, it's SO, opposite over hypotenuse. And we can use Pythagoras to find the missing length. It's going to be 4. It's a 3, 4, 5 triangle. 3 squared plus 4 squared equals 5 squared. And now we can write down cos theta. So we've got the opposite, the adjacent, and the hypotenuse. Cos theta is ka, adjacent over hypotenuse. Tan theta is toa, opposite over adjacent. But remember, because it's obtuse, cos and tan will be negative. So cos theta is going to be negative 4/5, and tan theta is going to be negative 3/4. One for you to try. Pause the video and give it a go. So cos theta is negative 5/13, and theta is between 180 and 270. So it's in this quadrant. Tan is positive, and sine and cos will be negative. So we've got 5/13. So 13 is our hypotenuse. This is our angle theta. The adjacent is 5. So this is the adjacent, the hypotenuse, and the opposite. We can use Pythagoras to find the opposite. So 5 squared plus x squared equals 13 squared. 13 squared, take away 5 squared. So 169 take away 25 is 144. X is square root 144, which is 12. So now we can just write down tan theta is going to be positive, and it's toa, opposite over adjacent. And sine theta is going to be negative, and it's SO, opposite over hypotenuse.